Hello and welcome to our session. My name is Peter Nikolov and I'm the Chief Technology Officer of Opsani. In this session, you will learn what continuous optimization as a service is and how to keep your applications at high performance with low cloud spend and at the same time have more time to implement value-adding features. Let me share with you an interesting fact. There are 7.5 quintillion grains of sand on Earth. Keep this in mind as we look at the complexity of optimizing cloud applications. The Google Online Boutique is a reference application that Google built in order to demonstrate the key concepts of microservice architectures and help train engineers on cloud-native applications. It's an open source application. It consists of 11 different microservices, each taking different function of the application. And it is mostly used to demonstrate best practices and understand how to operate and run applications in the cloud. When you look at deploying that application, how would you deploy this application in production and tune it, and the complexity of that tuning process, let's look at the number of variations, number of parameters that need to be tuned. There's 11 services. Each of these services has at least 2 tunable parameters. The CPU that will be allocated to it, the resource that will be given to it, and the memory that will be given to it. And each of the 11 services needs a specific value of the CPU and memory resource assigned to it. So if we look at, so there's 22 such configuration values. If we go with just 8 possible values for each of them, although this is conservative, there can be more, then we will end up with, we will see that there's 8 to the power of 22 or 75 quintillion different configurations that this application can take, and only one of them is optimal. Now, you will notice this is 10 times more different configurations than there's grains of sand on Earth. So how would you come up with the right configuration? How do we find the right configuration? Our answer is machine learning. This is the way to get to it. And to demonstrate this, what we did is we connected our continuous optimization service to the online boutique. We took the online boutique from GitHub repo as it is published as an open source application and ran it on a Kubernetes cluster. We looked at it, its performance and how much resources, what footprint it takes. And it was pretty straightforward to see that it was not running optimally. So we connected it to our continuous optimization as a service system. And these are the results. I'm going to give you the results that we got. We saw an 80% reduction in cloud cost. So you actually need to pay only about 20% of the cost for it. And at the same time, we're able to increase its performance. The result of that optimization is that after it's optimized, you can get 8 times more transactions per dollar in running this application. And we did this with about a 20-minute setup with one of our engineers. And it took approximately 2 days for our system to find that unique optimal configuration among the 75 quintillion. This is done, we did this with machine learning. Why do we need machine learning for this? Well, let's look at how we would do it differently, how you would do it with, let's say, brute force. If it takes you 1 second to try one of the configurations, it will still take 2,300 trillion years to go through the full configuration space, which even if in your business you can afford to wait that long, you can do it because the sun will go supernova in only 5 billion years. So this gives you, I hope this gives you an understanding of the depth and the complexity of the problem. And even if you go with more advanced algorithm, like you say, you can do binary search, the scale of the problem is so big that it cannot be solved through traditional means. Where I'm taking you with this is that tuning cloud workloads manually just is not feasible. Why? How are they different? For how cloud native applications different from traditional applications on which manual tuning was done? Well, the main thing is DevOps. The concept of DevOps brings tremendous velocity. That is how and this is a benefit that we specifically look for in DevOps. That's why we do DevOps. That brings rapid change in your application on a weekly and daily basis, in even hourly basis. So your code changes constantly. Your application runs on multiple platforms. You have 2 or 3 different cloud providers. You have vast configuration space. And the example that we just gave with only 22 parameters, with only 2 parameters per service, was actually very, very basic. The moment you add Java or any other sort of middleware, the number of parameters per service explodes, gets to 20 to 200 parameters per service. So there's tremendous amount of complexity in that configuration space. While doing traditional manual performance optimization is something that is reactive. It applies to the configuration and allows you to spend several weeks trying to tune it to the configuration and the code that was there 2 weeks ago or 8 weeks ago. Most teams don't even have a way to measure efficiency of how efficiently you're running. What is your coefficient of efficiency? And then